Hi everyone, my name is Lam, and today I will present a batch processing case study about Fred Meyer, which is a part of Crocker. The article I chose today focuses on Fred Meyer forecasting and replenishment process. It explains how the company uses sales history, demand patterns, and forecasting system to have stores decide how much inventory they should order. I choose this case because inventory forecasting is a very common but important data problem in detail, and store needs enough product to meet customer demand, but they also need to avoid carrying too much inventory. So this made Freshman a good example for the assignment because the business problem depends on the large amount of historical data, which make batch processing a reasonable solution. So we can see that the main business problem is inventory forecasting. Freshmayer need to ensure how much inventory should each store keep for each product. This is not easy because demand changes all the time. It can change because of holiday, this can change because of promotion, weather, or even the local customer behavior. So if the forecast is too low, the store may not order enough product, and that can lead to stock out, lost sale, and unsatisfied customer. On the other hand, if the forecast is too high, the store may order too much, and that create extra storage cost. And for grocery item, it can also create waste because some products may expire. So the goal here is to have Fredmail turn historical sale and inventory data into useful forecast, and it would have store order the right amount of product. The article does not provide Fresmeyer exact internal dataset, so I make reasonable assumption based on the retail industry. And we can see that the first data sort would be points of sale transaction data. This is created whenever a customer buys something. It would include fields like transaction ID, product ID, store ID, or the transaction time, so on. And this data is important because it shows what customer actually purchased, where they purchased it, and when the purchase happened. The second sort would be inventory record. This data shows current inventory level for each product at each store. It may include product ID, store ID, inventory level, inventory date, or the order point. And the third sort would be supplier shipment data. This help the company know what products are already on the way. It could include supplier ID, store ID, product ID, or the delivery date or the shipment quantity. And another useful sort would be loyalty card data. It can help identify customer purchasing patterns such as which products are often put together or which products are popular in certain location. And weather data could also be useful because can affect the demand. For example, hot weather may increase sale of bottled water and ice creams, and cold weather may increase the demand for soup or hot beverage. Before building any forecast, the data need to be clean and validated. So one common issue is missing values, another issue is duplicate record, and the third one is schema inconsistency. For example, one system may use product ID while another system may use SKU ID, and this may refer to the same concept, but Spark needs a consistent schema before trans and transformation can work correctly. And another challenge is data skill. In retail, some products generate far more transaction than others. So for example, milk or eggs or water may have much higher transaction value than slower selling item. So this can create uneven partition and slow down smart shop. So for this case, I would design the batch processing by line using the Medallion Architecture. So the byline had three layers, the bronze, silver, and gold. At the bronze layer, Prisma will load raw data with different systems into a data log or cloud storage environment. And for more detailed transaction and location data could be stored in Parquet because those datasets are large and need efficient analytics. Inventory records might come in CSV format from operational system. The shipment and weather data may come through ABLs in GSLN format. And the silver layer is where the data become clean and usable. So first, I would validate the data. I would fill out transaction record where product ID and store ID is none. And second, the quantity sold would be less than or equal to 0. The third, I would remove duplicate transaction using transaction ID to prevent the same sale from being counted more than once. And I would standardize data type, where transaction time and delivery day should be converted from string format into properly timestamp field. And after cleaning, I will start joining dataset. I would join sale data with inventory data to compare sale activity with available stock. And I would also join shipment data so the company can see not only current inventory but also the incoming inventory. The weather data could be joined by store location and data to see whether weather conditions affect the product's demand. And in Spark, this type would show data frame operations such as filter, join, group by, with column, drop, duplicate. After this layer, the raw data actually start become useful for analysts. So that's the time we move on to the goal layer, which contain the final business ready metric. So at this point, store manager and supply chain team need a clear answer that support decision. So one useful metric would be weekly demand. It can have estimate how much products a store may need for the next ordering cycle. Another useful measure would be day of inventory remaining. This would tell the business how many days a product can continue selling before it's run out. The byline could use group by and aggregation to calculate these metrics by store ID, product ID, and week. And I also partition the final outputs by year, month, and store ID because it would have Spark reach only the relevant data instead of scanning the full dataset. And the outputs could then fit a Power BI or Tableau dashboard for store manager and supply chain team and inventory analyst. So we can see the business value of this byline is better inventory decision making and which more accurate forecasting to Fred Meyer can reduce stock out, which have avoid lost sale and improve customer satisfaction. And it can also reduce excess inventory, which lower storage cost and reduce waste, especially for glory products. And the balance can also help supply chain team plan better because they can see demand pattern and reorder need more clearly. Well, actually, our cost concept has me a lot for this case. I have applied the Spark DataFrame, the Medallion Architecture, the batch processing, and parking and partitioning. And based on this concept, I hope that Fresno can build a scalable pipeline that's improve forecasting. I hope they can improve their inventory management and customer experiences. So, thank you for listening.